Imagine a huge group played by an unending number of stars, planets, and moons, all playing together superbly. In any case, there is one explicit portion of this ensemble that has dumbfounded space specialists for a seriously prolonged stretch of time. Exoplanets are customary planets that exist outside our planetary framework, hidden away somewhere deep in the Milky Way. You might be surprised to find that among the enormous number of cosmic objects, there are exoplanets so like Earth, so tantalizingly similar yet perplexing, that they might be our planet's heavenly twin. We plunge into the captivating area of Proxima b, found just 4.2 light-years away. The James Webb Space Telescope is revolutionizing our quest to understand these heavenly secrets. Imagine a moment when your mind ventures across the vast expanse of our reality. The Milky Way, which is home to more than a quadrillion exoplanets. That's a number with 15 zeros. To put this into perspective, if each of these exoplanets were the size of a grain of sand, we wouldn't just fill the Grand Canyon. We'd have enough to create another landmark on Earth, a Grand Canyon 2.0, stretching for considerable distance. What's truly astonishing is that around 20% of these celestial bodies have been classified as Earth-like in terms of geology and atmospheric composition. That means there's a 1 in 5 chance of finding a twin of our planet. And the story doesn't end there. Alongside these planets, there could be another quadrillion moons, rocky satellites like our own moon, locked in a gravitational dance with their parent planets. If you're pondering the possibility of finding another celestial body that harbors life, the universe offers an abundance of opportunities. Since we've laid out the grand cosmic scale, it's time to introduce the master artist ready to paint its intricate details, the James Webb Space Telescope. This heavenly Sherlock Holmes, with its advanced optical instruments, surpasses even the most developed telescopes. And we're not just talking about any lens. Its 6.5-meter-wide mirror is 2.7 times larger than Hubble's. Imagine the level of detail it can capture, detecting even the faintest glimmer of a star billions of light-years away, and then zooming in on the specifics of orbiting planets. What makes the James Webb Space Telescope revolutionary isn't just its observational power but also its cutting-edge technology, including advanced sensors and spectrographs. These instruments do far more than just observe. They analyze and filter light signatures emitted or reflected by celestial objects, deciphering their composition, density, and even mass. Acting like a space scientist, the telescope can determine whether a planet has water, organic compounds, or even oxygen. The James Webb Space Telescope has the capability to answer these questions, elevating it from a mere observer to a scientific powerhouse. It's not just an improvement over Hubble, it's a quantum leap forward. If Hubble's discoveries amazed you, prepare for a new era of astronomical revelations. As we expand our gaze across the vast cosmic landscape, it's worth focusing on one particular star in this celestial performance, Proxima b. Since its discovery in 2016, this mysterious planet has stood out like a Shakespearean character, full of complexity and contradictions, astonishing both astronomers and anthropologists alike. What's all the fuss about? First of all, Proxima b is practically in our galactic neighborhood, just 4.2 light-years from Earth. To put that in perspective, if you could travel at the speed of light, you'd arrive in just over 4 years, about the same time it takes for your favorite TV show to complete a few seasons. But let's dive deeper into why this proximity is so crucial. We're talking about a universe spanning more than 93 billion light-years across. Finding a planet this close and this scientifically promising is like discovering a diamond in a mountain the size of Mount Everest, a diamond that may hold secrets about life itself. In the grand tapestry of the universe, Proxima b is a multi-layered thread, offering profound clues that could redefine how we understand habitability and life beyond Earth. It's not just Proxima b's proximity that excites scientists but also the tantalizing evidence suggesting this planet is not just Earth-like but possibly Earth 2.0. Proxima b sits comfortably in what astronomers call the habitable zone of its parent star, a region where conditions are neither too hot nor too cold, but just right for liquid water to exist. Imagine waterfalls, winding rivers, vast lakes, and maybe even deep, mysterious oceans like the Mariana Trench. But before we start fantasizing about vacations on Proxima b, let's consider a few peculiarities. For starters, A single day on this fascinating exoplanet lasts an astonishing 11 Earth days. Imagine a sunrise that not only welcomes a new day but unfolds slowly, resisting the arrival of noon, with sunsets lingering for hours. A dream scenario for photographers. While this may sound idyllic, it has significant implications for its atmosphere and habitability. How would human biorhythms adjust to these prolonged light and dark cycles? Would we need to eat 3 or 4 times as much in a single day? Would we even sleep the same way? The fundamental patterns of life as we know them would be both tantalizingly familiar and frustratingly alien. Perhaps nature is posing a paradox, wrapped in a mystery, challenging our understanding of what makes a planet habitable. You might wonder, how can we gather accurate and reliable data about a world we've never visited? This is where the James Webb Space Telescope comes in, wielding its capabilities like a giant Swiss Army knife. It's more than just a telescope. It's a sophisticated research laboratory in the vacuum of space. Thanks to its innovative technology, astronomers can do more than just observe planets. They can analyze them through a scientific lens so advanced that even CSI labs would seem simple in comparison. Using advanced spectrographs, the Webb telescope can analyze light emitted and reflected by distant planets. Every element or compound in a planet's atmosphere absorbs or emits light at a specific frequency. By studying these patterns, scientists can perform a remote biopsy of celestial bodies, determining their atmospheric pressure, density, and even the possible presence of life-essential compounds like water, carbon-based molecules, and oxygen. The search for Earth's twin is closer than ever, and the James Webb Space Telescope is leading the way into this awe-inspiring frontier. Crime scene investigation isn't anology. It's space criminal science. We don't sit inactively, trusting that hints will come to us. We actively look for them, examining the atoms and molecules that make up these complicated universes. The Webb telescope isn't just an eye in the sky. It's a highly specialized investigation lab, scientist, and cosmic detective all in one. It allows us to transform our hypotheses about alien worlds into systems to verify or refute them, revolutionizing our understanding of what could exist beyond our blue planet. Just when you think you've uncovered the most stunning layers of this galactic mystery, the story takes an unexpected turn, much like in any sci-fi thriller. Scientists using the James Webb Space Telescope discovered something astonishing from Proxima b. A transmission so remarkable that it spread through academic circles and social media. Dubbed a potential technosignature, it was an electromagnetic signal so complex and intricately structured that it could point to the presence of an advanced civilization. The collective heartbeat of humanity seemed to pause at the peak of this discovery, a moment that promised to reshape our understanding of reality. Could this transmission be undeniable proof that we are not alone in the universe? Yet, just as quickly as it appeared, the transmission vanished without repeating itself, leaving behind an overwhelming silence and a labyrinth of unanswered questions. Was it simply a transient celestial anomaly, a cosmic coincidence, or something more deliberate, a coded message, perhaps even an indication of extraterrestrial intelligence? The solitary signal cast a shadow of mystery over Proxima b, igniting intense discussion and speculation. Was it just a fleeting oddity, or was it part of a much larger and more complex story? But wait, the story of our cosmic exploration is far from over. The ink has not yet dried, and new chapters are still being written. This time, it's not just traditional astronomers but also Harvard scientists leading a paradigm shift in the search for extraterrestrial life. They are not content with merely investigating the transmission and anomalies we've observed so far. Instead, they are raising the stakes, turning the James Webb Space Telescope into a kind of giant night vision device. Their goal? To search for artificial light sources in both the dark and illuminated regions of distant worlds. Imagine the possibility of detecting alien cities glowing in the darkness, their artificial lights shining across the vast cosmic oceans. What if we were to witness beams of light, a bustling metropolis emitting its glow into space? As we continue unraveling the mysteries of the universe, our quest for extraterrestrial life takes on new dimensions. Beyond Proxima b, our grand search extends into the endless reaches of space. This pursuit is driven by technological advancements and a profound curiosity about our place in the cosmos. Breakthroughs in astronomy and space exploration have led to the discovery of numerous exoplanets with potential habitability. Instruments like the James Webb Space Telescope, biosignatures, and ground-based observatories have expanded our ability to detect and study these distant worlds. One particularly fascinating area of research is the search for biosignatures, indicators of life. These signs could include atmospheric gases like methane or carbon dioxide, which, under the right conditions, could suggest biological processes. JWST's ability to analyze exoplanet atmospheres, combined with the potential to detect artificial light, takes our search to an entirely new level. The hunt for extraterrestrial intelligence, once confined to science fiction, is now a legitimate scientific endeavor. Researchers are refining their methods, hoping to uncover the signal that will answer humanity's age-old question: are we alone? So next time you look up at the stars, remember that the universe is vast, and the search for life beyond Earth is just beginning. The James Webb Space Telescope is our most advanced tool, unlocking discoveries that could answer the most profound questions of existence. As the search for extraterrestrial life continues, the role of JWST cannot be overstated. It serves as humanity's most powerful instrument, peering deep into the universe and exploring worlds once thought unreachable. Its extraordinary capabilities are pushing the boundaries of our knowledge, offering insights into distant planets and their potential to harbor life. By studying the atmospheres of exoplanets, especially those in their stars' habitable zones, scientists are charting a path that could one day lead to the discovery of life beyond our planet. While Proxima b remains a focal point, the scope of exploration extends far beyond this single exoplanet. The search encompasses countless other worlds, each potentially holding secrets about life's nature in the universe. New discoveries are happening every day. As technology evolves, so does our ability to analyze more distant and complex planets. JWST's capacity to detect biosignatures, substances that could indicate biological activity, is a game changer. These biosignatures might be gases like methane or oxygen, which on Earth are closely tied to life processes. If such gases were found in an exoplanet's atmosphere, it would be a strong hint that life might exist, or may have once existed, on that world. But the search isn't limited to natural life. The potential for discovering technosignatures, signals from advanced civilizations, is also a key goal of modern astronomy. The recent intriguing transmission from Proxima b raised the possibility that one day, we might truly encounter extraterrestrial intelligence. Such a discovery would be one of the most profound in human history, confirming that we are not alone in the cosmos. As scientists continue to analyze this transmission and others like it, they are also preparing for future missions to gather more data and make definitive assessments. Technosignatures could take many forms: radio transmissions, electromagnetic radiation, or even the detection of artificial structures. The thrilling possibility challenges our very understanding of intelligence and civilization. Moreover, JWST's ability to detect artificial light from distant exoplanets opens up an entirely new frontier in the search for extraterrestrial intelligence. Could we one day look through JWST's lens and see the faint glow of city lights on an alien world? The idea of discovering a thriving civilization, completely foreign yet so similar to our own, is mesmerizing. It raises profound questions about the nature of life in the universe. Have other intelligent species developed in ways we can't even imagine? Perhaps, like us, they have reached a point where they are reaching out into the stars. The possibility of finding extraterrestrial life, whether microbial or intelligent, would be a turning point for science and humanity. It would not only answer age-old questions but also spark new ones. If life exists elsewhere, what does that mean for our place in the universe? Are we part of a larger cosmic family? And how would we communicate with beings beyond our world? These questions go beyond science fiction. They are becoming part of our scientific reality. The discoveries made by JWST and future space missions will reshape how we understand our existence.